Hi, scientists. Miss Snowden here again, and I am going to talk about two more spheres we're going to add to the other three that we just talked about in last lesson. We talked about lithosphere, so I remember it being lithosphere, land, and we talked about geosphere, geography, ground. They all deal with the earth and the surface of the earth and a little bit lower. And then you also talked about oh goodness, escaping me right now. Um, I'm cheating. Nope. Biosphere. Bio has that prefix biography or biology, and so when we think of biology, we think of plants and animals. Okay, and so all of those two mixed together work together. Okay, plants and animals living on the ground and all of that kind of stuff. Well, we're going to add these two, and you're going to find out that all four of these really rely on each other. All right. They put these two together, hydrosphere and atmosphere, together because they kind of work really close together. But we're going to find out that hydrosphere and atmosphere, water and air, all we depend on that too as animals. And so when we look at the word hydrosphere, it has that prefix or that first word part that is in the front of a lot of words like hydrate. Okay, making sure you drink a lot of water. Okay, hydrant, like the fire hydrant, the magical fire hydrant of Canyon Ridge behind our school here. All right, it is full of water, so put out fires. All right, all of those different kinds of words all have to deal with water. All right, now atmosphere has the first part, atmosphere, okay, meaning air. Okay, hydrate, atmosphere, air. So those are the ways that I kind of trigger myself to remember the differences between of those spheres. And so let's look at this greenhouse. This greenhouse acts like the atmosphere. And as you read this paragraph, and I'll let you read it in just a second, you will see that it's not necessarily a house that's green. It is actually a house that helps green things survive. So in here, in case you have cold evenings and stuff like that, you have your plants, they can be inside this greenhouse. And so it will have the sun's rays. It allows the sun's rays to come in and warm up that plant, also give it its energy, its photosynthesis. All right. And it also will stay warm in there. So it will trap some of that some of the sun's rays in there to make it warm for the plants to survive. It's kind of like you putting on a blanket when you're cold. You'll notice that once you put the blanket on, you almost immediately start to feel warm. Your body heat is leaving your body, but that blanket gives it that extra coating on the outside that kind of traps that warm air underneath the blanket. And that's exactly what this greenhouse does. And we're going to compare that to the atmosphere and how it takes care of the earth. But I'm going to let you stop the video so that you can read this paragraph and get yourself updated on what this greenhouse does. And when you're done, I'll meet you on the next page. Okay, here we are now at the hydrosphere. It says here, and I don't know if you can see it very well, but I do have it highlighted here, that all the water on, under, or above the Earth's surface makes up the hydrosphere. So most water on the Earth is salt water. You're going to find out about 78%, a good portion, 78% of the entire Earth is covered in water. Okay? And of all of the water on the Earth, did you know that 97% is what we cannot use or drink? And that's scary because that only leaves 3% that is fresh water. And we need, as it says here, we need fresh water to survive. All right. We can't drink the ocean water. It tastes bad and yeah, it's got fish stuff in it. And so, yeah, it's not very good for us. And so we need to watch out for all of that that's going on and take care of our water. And so on this page, you're going to see that you have precipitation, so water coming down from the sky, whether it's rain, sleet, or snow. Okay, you have your ocean water, so that's on and above the surface of the earth. And we have a stream that's on the surface. Let's go ahead and look at the next page. Water vapor that's always floating around us. We can't see it, but we can sure feel it like on a summer day. All right, then ice and snow and all of that comes down as more kinds of precipitation. All right, the lake and then the groundwater. The groundwater is one of our major sources of fresh water. Now we have lakes and we have the streams, but the most fresh water, you'll be shocked, is not under the ground. Most of the fresh water that we have is hidden away in glaciers and in ice. And so that is not where we can get at it very readily. So there's this really, really, I mean, it's already 3%, even smaller percent that is groundwater that we have to take care of and keep it safe for all of us. All right. So I'm going to give you a moment to look back and watch this or look over these pages again and read this paragraph. And then I'll meet you on the next page. Okay. I love this page right here because it makes a great transition. If you'll look first, let's look at this earth right here. Notice that most of it is blue. Well, that is exactly what we just learned from the other page, is that our earth is mainly covered in water. Okay. And so we have a lot of water on that surface. And so now, let's take it from there and let's talk about the atmosphere. You'll notice that they have a little cloud bubble around the earth. Well, that's going to represent the layer of mixed gases that is around the earth. And that's what we call our atmosphere. Now, in this atmosphere area, we have a lot of different gases. Now, we've already talked about, because we talked about plants and animals exchange carbon dioxide and oxygen with one another, but there are other gases there like argon, nitrogen, and water vapor. And so consequently, these things we cannot use. Some of the things we need, but we cannot use. And so believe it or not, and if you'll look right here, this sentence right here, this is one of the very most important sentences right here. It says, the most plentiful gases are nitrogen and oxygen. Of all of that, did you know that when you breathe in a breath of air, so I'll let you breathe in a breath of air. Okay, breathe out if you need to. All right. Would you be shocked to know that, goodness, only 20% of that is oxygen? Yeah, that means if you had 10 pennies right in front of you and you picked up two, that would be, or 10 dimes, I'm sorry, and picked up two, that would be 20% of that breath that you just now took is oxygen. The rest of it is all of these other gases, and most of it is going to be nitrogen. All right, that just blew my mind when I first realized that or found that out. That was just crazy. So again, just like with water, a very small percent that is fresh water that we can use, very small percent of oxygen. That's why it's very important we are taking care of our water source and our air around us. Okay, that's why hydrogen, or the hydrosphere and the atmosphere, are very, very important for us. All right. And so if you look at these arrows in the next paragraph, it talks about how to look at these arrows. You're going to see that the Earth's atmosphere absorbs most of the sun's UV rays. Those UV rays are the ones that give us a sunburn, and and it's very harmful to your skin and all that kind of stuff. So you want to be thankful for that atmosphere because it does protect us from the sun's harmful rays. All right. But as we talked about, some of it will go through, all right? And it will keep the earth warm. Kind of like if you remember on the very first page that we talked about, that greenhouse, it actually keeps some of that warmth like a blanket on the surface of the earth. So it keeps the oceans from freezing, it keeps us from freezing, it also protects us. And so this keeps us uh, and that's what helps us as a planet as opposed to the other ones that supports life on the surface, because that would be kind of important to us, I believe. All right, so I'm going to give you a moment to read and highlight what you have if you have your book, and these are very important thoughts and ideas that you need to take note of for your assignment. So I'll give you a minute to read this over, and then you can start the video on the next page. Okay, so here we are with the hydrosphere and the atmosphere together. Oh my goodness. And if I'm not mistaken, I believe there is today or just recently a Hurricane Nicholas. All right. Now, if this is being viewed later on, Nicholas is probably, long gone by now, but there is a hurricane that is forming. And this is what happens when the hydrosphere and the atmosphere work together and interact. They always interact with each other, just like they do with the others. But here is a big example of what can happen in the atmosphere with a bunch of water involved. All right. And so it says here that the hydrosphere and the atmosphere constantly interact, and both rain and snow are common in many parts of the world. The temperature of the air, so that would be the atmosphere, affects the kinds of precipitation, that would be the hydrosphere, that falls. So in other words, when it's cold outside, we may get snow. All right. If it's cold and windy outside, we may get sleet or hail. If it happens to be warm outside, the rain's going to continue to stay. It's going to come down, and it's going to start warming up, and it's going to come down as rain. So this is what actually gives us the types of precipitation, the water that falls down from the sky because of the atmosphere. All right. So this hurricane is a large, swirling tropical storm. They bring damaging winds, and they carry a lot of water with them. Okay. So rain comes down, and water vapor as well, and all of that. And it's because they usually form over a warm ocean water. And we have warm ocean water over in the Atlantic. Okay. And it's usually down in Florida, closer to the equator-ish, and then it kind of comes up a little bit, and it hits our eastern coast most of the time. If conditions are right, the tropical storm will produce clouds that will spiral with a lot of wind, and it will look like this in the photo. So this is from a picture of a satellite that's high above the earth. You can see the green there on the left, and the water on the right, and maybe that peninsula right there could just be Florida. All right. And so the speed and pattern of the winds in this storm distinguish or make a clear difference between a storm and a hurricane. All right. Now, we're familiar with swirling winds, and that is a tornado. But our winds that make tornado do not carry a lot of moisture with it. Now, it will carry some, I'm not going to lie, but most of it is just strong, powerful winds. So we'll talk more about weather later on, but this happens to be your hydrosphere and your atmosphere to go along with your other spheres. So Go back, read these 2 paragraphs, and then answer your questions. Please go back and look at your workbook pages and prove your answers correct. And remember to do your quiz twice so that you can get the best score possible. All right, see you later, friends. Stay curious.